All right, ready to dive into something pretty wild.
I'm ready. Let's do it.
Today we're looking at DeepSeek-R1.
Okay.
You know, those large language models.
Uh-huh.
This one, though,
Yeah.
this one can reason through problems.
Oh, wow.
Like it's solving these complex puzzles, you know?
Really? Like a super brain.
Yeah, exactly.
That's interesting. What makes DeepSeek-R1 so different?
Well, it learns through reinforcement learning, or RL.
Oh, RL. So not just mountains of data.
No, it learns by doing
By doing.
and gets rewarded for correct solutions.
Interesting. So it's like us. Trial and error.
Exactly.
That's a big deal, isn't it, for developing these models?
QGE means we
Okay.
can improve them without needing, more data. Makes development way more efficient.
Wow. Okay.
So before we get into DeepSeek-R1 itself, let's back up.
Okay.
The research, it actually started with this model called DeepSeek-R10.
Right. DeepSeek-R10. That was trained purely through RL.
No pre-existing data.
No. No hand-holding. They basically set it loose in this world of problems. Let it figure things out
From scratch.
from scratch.
Yeah, sink or swim. So did it learn anything useful that way?
It did, which is pretty amazing, honestly. Shows how powerful this approach is.
And as it trained?
As it trained, DeepSeek-R10 started, showing these really remarkable reasoning behaviors.
Okay, I have to ask, give me an example. What kind of reasoning behaviors are we talking about?
Well, they noticed as it trained, right, DeepSeek-R10, it started allocating more processing time.
To solve problems.
Yeah, to solve the problem.
Like it was like deciding to think harder.
Yeah, it's like it was thinking, this is tough. I need more time.
Hold on, I'm looking at the paper now. Is this what figure 3 shows? The average response length increasing
That's it. The longer the response, the more complex thinking is going on.
to get to that solution.
Yeah.
Wow. Okay, so it was learning to strategize.
It really seems like it.
But did it actually get better at solving problems?
Oh, yeah. Way better, on like benchmarks and stuff.
Like what?
Well, on the AM 2024 math exam, you know that one?
Yeah.
DeepSeek-R10 went from a terrible, like 15.6% pass rate to a huge 71%.
Wow. Okay. Failing to better than most high schoolers on a tough exam.
Right. Big leap.
Yeah.
And then there's this.
What?
They saw what they call an aha moment during one of the tests.
An aha moment. Okay, now I'm really listening.
So they're testing it, right, with this really hard math problem.
Uh-huh.
And it starts down one path.
Okay.
Then it seems to realize, wrong direction.
It hit a dead end. So what happened?
Well, in Table 3 of the paper, it says, the model actually paused and generated this phrase, wait, that's an aha moment I can flag here.
It said that
Yeah.
out loud, like it recognized it made a mistake.
It did. And
What did
then
it do?
backtracked, reevaluated, and actually found the answer.
This is incredible. Catching its own error and fixing it.
Right. That's reasoning. That's what's so cool about this RL stuff. We're not, like, programming them to think a certain way.
And giving them the tools.
Yeah, and the motivation to learn on their own. You get these surprisingly sophisticated strategies.
So DeepSeek-R10 was a big deal,
Huge.
but it wasn't perfect.
No.
And that's where DeepSeek-R1 comes in.
Exactly. DeepSeek-R10, it proved the concept. But there were limitations, like the reasoning. It was kind of hard to follow.
For humans.
Yeah, for us. And it sometimes jumped between languages within the same problem. Not ideal.
No, not if you're trying to understand its logic.
Exactly.
So they needed to make it, like, more user-friendly.
Yeah, more human readable.
So was DeepSeek-R1 designed to be more user-friendly then?
Yeah. So they trained it, using a bunch of techniques,
Okay.
including a small set of cold start data.
Cold start data.
Yeah, it's like basic instructions, examples, to help it learn.
Hmm.
Think of problem solved in a clear step-by-step way.
Okay, so that was the first step.
Mhm.
And then, did they bring back the RL?
Oh, for sure. RL was still like the core of it.
Okay.
Actually, DeepSeek-R1 was trained in 4 stages.
4.
Yeah, we talked about the cold start. That was the first. Then second stage. All about reasoning-oriented RL, like DeepSeek-R10. But this time, they added a reward for language consistency.
So stick to one language.
Right. One language at a time.
So not just solving problems, but explaining them clearly.
Exactly. In a way we can get it.
Okay, so what about stages 3 and 4?
Stage 3, they use something called rejection sampling.
Okay, what's that?
Imagine the model's generating, like, multiple solutions to a problem, right? They only keep the good ones, the correct ones, and the ones that are well-structured, no confusing stuff.
Like a quality control filter.
Yeah, exactly. Only the best get through. Then they use that filtered data, plus some from their previous model, DeepSeek V3, to refine DeepSeek-R1 even more.
Okay, final stage. More RL, I'm guessing.
Yeah, but this time, bigger focus.
Bigger how?
They wanted to make sure DeepSeek-R1 was, not just good at solving problems, but helpful.
Helpful.
And harmless.
In all situations.
Right. So they trained it on all kinds of prompts. Like some required it to be informative, unbiased, avoid generating, anything bad.
So the final stage was like instilling responsibility.
Yeah.
Making sure it's not just super smart, but also like a good citizen.
Yeah. Make sure it's aligned with, human values.
A tall order.
It is, but necessary, right?
Definitely. So after all that training, how did DeepSeek-R1 actually live up to the hype?
Well, it's important to note, even with all that, DeepSeek-R1 wasn't perfect.
Ooh, it still had some limitations.
It did. It wasn't as good at some general tasks.
Like what?
Like multi-turn conversations or generating structured data, like JSON, compared to some other models.
I see.
And, while they made progress
Yeah.
on that language consistency thing, it could still sometimes, struggle with mixing languages.
Okay.
Particularly with queries that weren't in English or Chinese.
So some work to do there to make it a truly versatile model.
Yeah.
But I'm guessing it still performed pretty well overall, despite those limitations.
Oh, yeah. The results were impressive.
Okay, good. What were some of the tests?
They tested DeepSeek-R1 on a bunch of things.
Okay.
Including some really challenging benchmarks.
Like what?
Like the AM 2024 math exam.
Oh, wow. Yeah.
And the Codeforces coding competition.
Those are tough. How'd it do? I'm dying to know.
Well, on the AM 2024,
Yeah.
DeepSeek-R1 got almost an 80% pass rate.
Wow.
Which is actually a bit better than one of OpenAI's top models, O1 1217.
Oh, really?
Uh-huh.
Okay.
And on another tough math benchmark, Math 500,
Yeah.
it got almost a perfect score.
Oh.
97.3%. No way.
Yeah.
Again, on par with O1 1217. And then on the Codeforces competition, it actually beat over 96% of human participants.
Wow.
Achieved an expert level rating.
Serious stats. So it sounds like DeepSeek-R1 is a major step forward
I think so.
in creating large language models that can reason more like,
Like humans.
Yeah.
Right.
This is mind-blowing.
It is pretty cool.
But before we go any further,
Okay.
there was this other aspect of the research
Yeah.
that I found really fascinating.
What's that?
You mentioned they didn't just create this one super powerful model.
Oh, right.
Yeah.
The distillation thing.
Distillation. Yeah, that concept sounded kind of technical to me.
Yeah.
Can you break it down in simpler terms?
Sure. So imagine you have this master chef.
Okay.
Who knows this super complex recipe.
Uh-huh.
But instead of having everyone, try to make it from scratch, they make a simplified version that captures the essence of the original dish.
So they're basically using DeepSeek-R1's knowledge and expertise to teach smaller models how to reason.
Exactly. They use its outputs, its reasoning process, the solutions to train these smaller models.
Like they're learning from a mentor.
Yeah, really good one.
That's really cool. But did it work?
Surprisingly well.
Really?
Especially for math and coding. For example, they distilled DeepSeek-R1 into a model with only 7 billion parameters.
Okay.
Which is way smaller than the original.
Right.
And even this mini version outperformed much larger models that weren't trained using distillation.
So it's not just about the size anymore, huh?
Nope.
It's about how well it can reason.
That's what matters.
That's a big deal.
Huge.
For accessibility.
Yeah, absolutely.
This means we could create highly capable reasoning models that are way more efficient.
So much more efficient to run.
Even on, devices that don't have much power.
Exactly.
This is where it gets exciting for me.
I know, right?
If we can get these smaller, distilled models performing at a high level, think of the possibilities.
So many possibilities.
AI assistants that can actually help us think through complex problems.
Not just answer simple questions.
Right, exactly.
Or do basic tasks.
This is big.
Huge.
But let's, zoom out for a sec.
Okay.
Why should the average person care about any of this?
That's a great question.
Yeah, what's the real-world impact?
Well, practically speaking, This research could lead to some really powerful AI tools
Okay.
in a ton of fields.
Okay.
Like imagine AI assistants that can help scientists analyze complex data or,
Yeah.
assist engineers
What?
in designing better products.
I see.
Or even, support doctors in diagnosing diseases.
More accurately.
More accurately, yeah.
So we're talking AI that can actually help us augment human capabilities.
Not just replace jobs.
Exactly. But I think it goes beyond just the practical stuff.
Yeah.
DeepSeek-R1 raises some pretty fundamental questions about the nature of intelligence.
Ooh, that's deep.
If we can teach machines to reason
Independently.
what other, human-like cognitive abilities could they develop?
Yeah, that's the question, isn't it?
It's like sci-fi stuff.
It really is.
But now it feels a lot more real.
Way more real.
And it's not just a question for scientists and engineers.
No.
It's a question for everyone.
Definitely.
We need to be having these conversations.
For sure.
Exploring the potential benefits and risks.
Totally.
Making sure we're shaping this development in the right way.
In a way that benefits us.
Exactly.
Exactly.
So where do we go from here? What are the next steps for the researchers?
Well, they've said this is just the beginning.
We're going to keep going.
Oh, yeah. They're already working on improving DeepSeek-R1.
Okay.
Making it better at, general stuff and fixing those limitations with language mixing.
Okay.
Trying to make it even more efficient.
And robust.
Exactly.
And I imagine they're not the only ones.
Oh, definitely not.
Working on this.
There's a whole bunch of research labs and companies
Right.
racing to develop their own models.
Focused on reasoning.
Yep.
It's moving so fast.
It's insane.
As we see more, advancements.
In RL and other AI techniques,
Yeah.
we can expect even more crazy developments.
In the coming years.
Oh, for sure.
It's exciting, but also a little bit.
Scary.
A little bit, daunting.
Yeah.
The possibilities are limitless, but we got to be careful.
I agree.
Approach this thoughtfully.
Responsibly.
Yes, responsibly.
I think, the more we know about AI,
the
better we'll be able to navigate it.
Navigate its impact.
Yeah.
This has been incredible so far.
It has been fun.
We've covered a lot.
We have.
From that aha moment in DeepSeek-R1
That was a good word.
to the potential for smaller models in the future.
More accessible.
Yeah. But before we wrap things up,
Okay.
I want to hear from you.
From the listeners.
Yeah. What are your thoughts on all of this? What stands out to you as we, finish up our deep dive into DeepSeek-R1? What's going to stick with you after this? The aha moment. The potential of making AI more accessible. Or something else entirely.
What really gets me is this idea that we're seeing, a new kind of intelligence emerge, DeepSeek-R1 and models like it. They're not just like fancy calculators. They're solving problems. They can reason, strategize, learn from mistakes like we do. It really challenges what we think AI can do.
It's happening so fast, too. People think human-level AI is way off in the future. But this is a wake-up call. It's exciting, but a little unnerving, too.
It is, and that's why it's good to talk about this stuff openly. We need to understand both the good and the bad so we can, guide it the right way.
So if you're listening and you're as fascinated by this as we are, let us know. Head over to our social media, share your reactions, questions, or any aha moments you had. Let's keep talking about this.
Yeah, because the future of AI, it's not just happening to us. We're shaping it right now. The more we know, the better choices we make.
I love that. Okay, one final thought to leave you with. If these models can learn to reason independently, even show signs of self-awareness, like DeepSeek-R1, could they develop other human-like abilities, empathy, creativity, even consciousness?
Wow. Those are some big questions. Pushing the boundaries of what we know. I don't have the answers, but we should be asking them. These questions could shape the future of our species.
It's exhilarating and intimidating to think about where this could all lead. But one thing's for sure, this is just the start of the AI revolution.
Keep exploring, keep questioning, keep the conversation going. We're all part of writing the future of AI.
And that's what the Deep Dive is all about. Thanks for joining us on this journey, and we'll see you next time for another deep dive into the world of knowledge and discovery.